Okay, let us continue. We'll see the next thermodynamic property, that is called as enthalpy. What is enthalpy? Enthalpy is nothing but heat content of a system. Enthalpy is nothing but heat content of a system. Okay. Now what is this equal to? This is equal to U plus PV. H is enthalpy, U is internal energy, and any pressure volume relationship associated with the system is denoted as PV. So it is the sum of internal energy and any pressure volume relationship associated with the system. Generally we are talking in terms of gas. Okay. And enthalpy is a state function. Why it is a state function? Because it depends only on the initial and final states of the system and not on the path followed. Okay. Okay. And in general, the reactions are carried out at constant pressure and not constant volume. Atmospheric pressure पे करते हैं, room temperature पे करते हैं, ठीक है? Volume का हम ये नहीं करते हैं. Now, you know the first law of thermodynamics, delta U is equal to Q plus W, and this can be written as Q minus P delta V. Work done can be replaced as minus P delta V. This also you know it already. Now at constant pressure, you are representing the subscript P here, heat absorbed at constant pressure, and minus P delta V is the expansion work done by the system. Now, the change in internal energy is equal to QP minus this P delta V you wrote, is it not? This delta V is what? V2 minus V1 or V final minus V initial, right? So that is what you are putting it, and you are expanding the equation. You will get like this, and then make the QP remain on one side and take all the other items on the other side, and then you will get this expression. Now from this what you understand? This is U2 plus PV2 and U1 plus PV1. Because why P only? Because it's all done at constant pressure. Okay. So you can write that this QP, it is nothing but delta H. Okay. QP is nothing but delta H, that is enthalpy change, which is nothing but H2 minus H1. This is H2 minus H1. Okay, that is QP. And now this expression, if you want to express in terms of the change in enthalpy and change in internal energy, you will get delta H is equal to delta U plus delta PV, right? Why delta PV? This PV I am going to differentiate it with respect to each parameter. In the first condition I'll write change in volume with respect to constant pressure, and then in the next step change in pressure with respect to constant volume. So I'm going to relate one in terms of the other. So I'll get P delta V plus V delta P. यहाँ पे P को constant रखे change in volume किया, यहाँ पे volume constant रखे delta P, that is change in pressure denote किया. Now if P is equal to 0, delta P is equal to 0, then this term will be eliminated. With the result you will have delta H is equal to delta U plus P delta V. Now, since P delta V can be equated to nRT according to ideal gas equation, PV is equal to nRT, right? So you'll have delta H is equal to delta U plus delta NGRT. P delta V is replaced by delta NGRT. Okay, what is this delta Ng? It is number of moles of gaseous products minus number of moles of gaseous reactants. That is what is delta Ng. That means you're going to take only the products in the form of gas and reactants in the form of gas for this particular expression. You will not take liquids and solids into consideration at all. Okay. Now these are the expressions we have so far seen, right? That's what I have given.